is titled Solving Systems of Equations. It covers pages 11 through 13, and we're going to answer the question, how can I determine the intersections? Okay. For problem 61, they want us to consider the two equations. The first one, I used my blue pen for x squared minus 2x minus 8. We know because of the x squared that it's got to be that parabola, right? Okay, so that parabola is in blue. I also made a T-chart for it in blue. That'll give you some points so that you can see how your parabola is going to go. Once you find the vertex and the line of symmetry, you can match up points on different sides, okay? The second equation was negative 2.5x minus 3. That's obviously linear, so it's going to be a line. I did that one in orange. You can see the line going here. You have all these points on this T-chart. You can go back later and type this in Desmos, but for now, this is hard for me to switch back from the doc cam to the computer. You just have to believe me that I did it correctly, okay? All right, part B says, how many times do the graphs intersect each other? This one has an intersection right here and an intersection right here, so this one has two intersections. And here is how you will determine those intersections. They want us to estimate the points of intersection from the graph. Well, I mean, you can estimate it, or you can go into Desmos. You hover over those 2 points of intersections, and you'll get the 2 points at negative 2.5, 3.25, and another point of intersection at 2, negative 8. Any questions on the first problem, number 61? Okay. Awesome. What? You're still, okay, some people are still writing. I'll go back up. 62 says, using a graph to determine the intersection of two curves can be challenging when the points of intersection are not where the grid lines intersect or are outside the visible portion of the graph. Therefore, it helps to have another method for determining the points of intersection. What algebraic methods have you used to solve systems of equations? Discuss with your team members. So one of the ways you can solve is obviously by graphing. We were able to, you can see where the two graphs intersect. That would be their solutions. But you can also use a method called substitution. You can use a method called elimination, or you can use the equal value methods, which is what we're going to use in part B. Okay, so for part B, it says, use one of the methods you listed in part A to solve for the points of intersection of the f of x equals x squared minus 2x minus 8, and g of x equals negative 2.5x minus 3. Notice that those are the same two equations from the previous question. Okay, so essentially we should get the same answers, all right? Because they're both equal to f of x and g of x, which is essentially our y, we can just take those two equations and set them equal to each other. This is often called the equal value method. It can also often be referred to as substitution. You'll hear it either way, okay? So if we have the x squared minus 2x minus 8 on the left and the negative 2.5x minus 3 on the right, we want to get it set equal to 0. So we're going to add the 2.5x to both sides, and we're going to add the 3 to both sides. That'll leave us with 0 on the right, okay? We bring down the x squared, and then negative 2x plus 2.5x is plus 0.5x. And then negative 8 plus 3 is minus 5. Okay? This is not easily factorable, so we're going to use the quadratic formula on it. We're going to use the coefficients of each of the terms as our a, b, and c. So right here there's a 1, which you can't see. Here there's obviously a 0.5, and here there's a -5. Oh. Did that mess it up? Oh, there's supposed to be a negative sign right there. -5. Okay. That will make a difference. Okay. So we take, for the quadratic formula, we say that x is equal to the opposite of b plus or minus the square root of b squared, which is 0.5 squared, minus 4 times a, which is 1, times c, which is -5, all over 2a, and a is 1. We get our two answers by solving this in our calculator, once with adding and once with subtracting. Okay? So the two values we'll get are our -2.5 and our 2. Then you plug it back into either of the equations, and you'll get your y value. Notice that these two answers are the same answers we got. Where is it? Right here. These two answers are the same as these two answers. Question 61 was done graphically in Desmos, and question 62 was done algebraically using the equal values method. Okay, it's just two different ways of doing the same problem. Okay. Any questions on problem? Is problem 63, which is pretty similar to what we saw on the previous page, except when we graph the parabola and we graph the line, what do you notice about the parabola and the line? They're not touching, right? They're not intersecting, okay? So for the first equation, y equals x squared, I graphed it in orange. And the second equation, y equals 2x minus 5, I graphed it in green. It's the little line. They're not touching. Like the one on the other page, they intersected twice. These do not intersect. It says sketch graphs of both equations on the same set of axes and estimate the points of intersection. So instead of writing down where they're intersecting, we just say they do not intersect. Okay? For part B, now they want us to show by using algebra to solve the systems of equations. How does your solution relate to your answers in part A? Okay? So we're going to set the two equations equal to each other. That's called the equal values method. We want to set it equal to 0, so subtract the 2x and add the 5. That gives us a standard form, so we can take the coefficients of each term and get our a, b, and c. So in front of that x squared is a 1, in front of the x is a -2, and this constant term is a 5. So we're going to take those three numbers and plug it into the quadratic formula, which is x is equal to the opposite of b. b is -2, so you have the opposite of -2, which will make it positive. Then it's plus or minus the square root of b squared, which is -2 squared, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. What happens with this one, when you calculate, is you get a negative number under the radical, which gives you an imaginary number, and you end up with a solution of 1 plus or minus 2i. 2i makes it imaginary, which means it's not real. There's no real solution. Then you have no intersection of those two graphs. 64, which is titled, How Many Intersections? All right, in your teams of 4, you're going to be given a graph of two parabolas or a line in a parabola. It is usually easy to determine how many points of intersection they have. But how can you tell algebraically? So you're going to use an algebraic method of your choosing to determine the points of intersection, if any exist, for the system assigned to your team. So every team is going to get a different question. Examine your solution and decide what it indicates about the graph of the system. That is, do the parabolas intersect once, twice, Or do they never intersect? So there's going to be some questions that have 2 intersection points, some only have 1, some have none. That won't happen. Once you have solved your team system, sketch a graph to verify your conclusion. Okay? So when we split up into teams, each team is going to have a different problem. You're going to, on the left, show your problem algebraically over here, and then you're going to show it graphically over here. Okay? So you're going to do the algebra on the left, you're going to do the graph on the right,